Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on correlation in linear relationships. Please note as you watch this that students are required to have a table of critical values that test the claim that the slope is not zero. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. This is part 3 of this video, and we're picking up in the middle of a set of examples looking at a example on how to determine to check for a linear relationship. And we're looking at some examples where the n is 30. And in this case, notice that we've have a set of points, n is 30, and we have a general linear trend here. And we have screenshots from our TI-83 or 84 calculator. In the second screenshot, we have our results for our linear regression. Again, we will cover that in a different PowerPoint and some videos on that additional PowerPoint, which should be available to you. We need to find our R and our slope. Our R is given in this case as 0.8345. Again, Mrs. Borlaug is rounding to 4 places. Please round to whatever your teacher tells you to round to. Different teachers use different rounding rules. Our slope in this case is 9.7060, and that gives us a positive slope and a positive R value. The sign of the slope and the sign of the correlation coefficient are always the same. Our R is positive and the slope is positive. And here is a screenshot of the same data points with the equation drawn through it. And next, let's find the absolute value of R and the table value. The absolute value of 0.8345 is 0.8345. Remember that the absolute value changes the value to a positive or leaves it positive, in our case leaving it positive, and our table value for n equals 30 is 0.361. Is there evidence of a linear relationship? Well, yes. Explain how we know. Well, the explanation is twofold. Remember, we have 2 steps to check for a linear relationship, and we must do both. The scatter plot shows a general linear trend, and since the R value, or the absolute value of R, is greater than the table value, there is evidence of a linear relationship. Since there is evidence of a linear relationship, we can now answer yes to the question, should predictions be made using the linear regression equation? So yes, we can use the linear regression equation to make predictions. We can use the equation to make predictions. Let's look at the next example. Again, remembering we're going to use the 2 steps to check for a linear relationship. Here is our screenshot of the graph. Here is the screenshot of the linear regression. What is our R? Well, our R is 0.9608. What is our slope? 10.4937. The sign of the slope and the sign of the correlation coefficient are always the same. R is positive, the slope will be positive. Here is a picture or a screenshot of our graph with our points, with our line or correlation, or linear regression, excuse me, I'll get the right word out, with our linear regression drawn through them. What is the absolute value of R? It would be 0.9608, and our table value for n equals 30 is 0.361. And that does come from the chart of critical values for correlation coefficient. Is there evidence of a linear relationship? Yes. Explain how we know. because the scatter plot shows a general linear trend, and since the absolute value of R is greater than the table value, there is evidence of a linear relationship. Should predictions be made using the linear regression equation? Yes, we can make predictions. Let's move on to the next topic. Our correlation coefficient is positive, then our slope is positive. If the correlation coefficient is negative, our slope is negative, and if the correlation coefficient is 0, our slope is 0. The sign of the slope and the sign of the correlation coefficient are always the same. As x increases, the y increases. As the x decreases, the y decreases. The x and the y do the same thing. It's a positive correlation. In a positive situation, the x and the y agree. They do the same thing. Everybody's on the same page. Everybody's a happy camper. For the correlation coefficient is negative and the slope is negative, then as the x goes up, as the x increases, the y decreases. As the x decreases, the y increases. The x and the y's are fighting. They're going in opposite direction. They do the opposite things. This is a negative correlation. If you and someone else are doing opposites, it's a negative feeling because you're on opposite sides. So it's a negative connotation. So that's the negative correlation. In a correlation coefficient of 0 with a slope of 0, there is no linear relationship because linear relationships have non-zero slopes. This is important, so that's why we've covered it again in this video. And before we get to here, there looks like there's a lot of these, so we're going to stop here, and this is a good place to pause, and we will pick up here in the next video of this set.